In this video, we will explore three different joining processes: brazing, braze welding, and welding. We also clarify the fundamental differences between these processes. First, we begin with brazing. Brazing is a joining technique which relies on a metallurgical bonding between the surface of a material and a filler material. And this filler material exists between a gap between the materials that are to be joined together. In this process, we have a metallurgical bonding, which is bonding in the atomic scales between this filler material and the fairing surfaces of the adjoints. The important thing in this process is a gap, a clearance between the fairing surfaces that we have, and this clearance is very important in brazing technique. And the other thing is the overlap between the two materials that determines the strength of the joint. The gap that we have here is very important because of the capillary action that acts in this process, and I will speak about it in the next slide. The most suitable joint configuration for brazing is lap configuration. It is because in this process we need a clearance or a gap between the fairing surfaces, and this gap is very important. So imagine we have two materials that are to be joined, and we have a filler material here. This filler material should be melted and diffuse into the gap. For this filler material to be melted, we need a heat source. The heat source that we apply in this process should not be directed into the filler material, and we should avoid any direct heating of the filler material. It is because the filler material may encounter some selective evaporation of some of its alloying elements, which alter or degrade the mechanical performance of the joint. Instead of heating the filler material, we heat the adjoints. And when we heat the adjoints, and when the adjoints reach to a critical temperature, this temperature is conducted to the filler material. So the placement of the filler material here is very important, because we should have a contact with the base materials, so the heat can conduct it to this filler material. And the filler material should be melted only with the heat conducted from the base material. It is because the molten filler material flows in a direction that we have a temperature gradient, and this temperature gradient and the direction of the flow of the molten filler material is toward the higher temperature. The other important thing is in this process is surface preparation. In brazing technique, it is very important to have some surface preparations. I may discuss the surface preparation and the selection of filler material in future videos, but here I only speak about the fundamentals of this process. The other thing is that we may use some fluxes during the process, because this flux dissolves the oxide layer on the surfaces of the materials and also prevents the further oxidation. This oxidation inhibits the metallurgical bonding in this process, because this process relies on bonding between the surface of the materials and also the filler material. So the surface preparation is very important. But what capillary action is? Imagine we have a container, and in this container we have some liquid. We put a pipe. This is the cross section of a pipe. We insert it into this container. This fluid, this liquid that we have flows into this pipe, and sometimes we may see that the surface of this liquid inside the pipe stays above the free surface of the liquid inside the container. But why this happens? It happens because of capillary action, and this capillary action relies on an adhesion force between the liquid that we have and the surface of the solid wall that we have. And when this adhesion force that we have, and it acts in this direction, when this adhesion force is higher than the cohesion force that we have inside the liquid, it draws the liquid up, and that is why the surface of the liquid stays higher with respect to the free surface of the liquid. And the shape of the free surface is also concave because of this capillary force that we have, and this capillary force is based on the surface tension. The further detail on surface tension I will explain in another video. The gap, the clearance that we have, shows its importance here. The lower the gap that we have, the higher the capillary pressure, and this driving force that draws the liquid into the gap depends on the clearance. And when we decrease the clearance, we have higher pressure. But we should notice that this clearance cannot be lower than a critical value, because if we have a very narrow gap, the pressure, the driving force that we have is not enough to force the liquid into the gap. So we have a critical gap. And also it cannot be higher than a critical value, because this driving force that is caused by the surface tension reduces, and the liquid cannot travel an enough distance to make a joint between the two materials. Here I present you a practical example of brazing technique between the two pipes made of copper, and I found this example from an article which I referred here. You can find the article and read it if you are interested. But the important things from these articles is that we need to have a gap between the two tubes. That is why we should have such a geometry to make this gap, because this gap is very important. And the distance, the clearance of this gap is also very important. We place the filler material here. It is the filler material, and we heat the two tubes only in this area. And as I mentioned before, we should avoid direct heating of the filler materials. And after we reach a critical temperature, which I showed here, and I don't speak about the filler type that we have. It is the filler type, but the further detail you can find in the article. And also the temperature of the liquidus and solidus of this filler material. It is important that the liquidus temperature of this filler material be higher than the solidus temperature of the base materials. We should avoid any melting of the base materials in this process. And when we reach this critical temperature, and when the filler material is melted, it flows into the gap. And the time that we should keep the joint at this temperature is very important. This time should not be higher than a critical holding time, because it alters the properties of the filler material. And it is forced into the gap, and upon solidification it makes metallurgical bonding with the surface walls of the tubes. And this is the cross section of this joint that you can see. This is the outside tube, and this is the inside tube, and this is the filler material that is solidified, which is placed here. And this cross section is from across this line that you can see here, and this is the cross section in the longitudinal direction that we have here, as you can see here. And you can see that the molten filler material is drawn into the gap very completely. and we have wetting, complete wetting of the surfaces of two adjoints with the filler material, and this is an indicative of an acceptable brazing process. What about weld brazing? Weld brazing lies between welding and brazing. It has some similarity with both processes and also some differences between these processes. The similarity between weld brazing and brazing is that it relies on bonding between a filler material and the surfaces of two adjoints, but we don't need a clearance between two adjoints, between the fairing surfaces. We don't need a clearance, and because of that, we don't have any limitation on the joint configuration. We can do weld brazing in butt configuration and also in T configuration. We can deposit the filler material here and establish a joint. So we don't have this limitation. And the difference between weld brazing and welding is that in welding we have fusion of the base materials, but in weld brazing we don't have fusion. And the similarity is that we deposit the filler material like we do in weld brazing, like we do in welding. So as two examples, I showed you here the cross section of weld. Here we have a weld, and here we have weld brazing. And you can see here the deposited filler material. Here the filler material should be compatible with the base materials because the base material is melted and is mixed into the fusion zones, so they should be compatible. You can see here the fusion of the base materials, but here in weld brazing we don't have any fusion of the base material. We may have some slight fusion of the surfaces of the base materials, but it is not necessary to have this melting. So the procedures that we use to do weld brazing and welding have some differences, which I may discuss them in future videos if you like. And in this table I summarized the differences between brazing, weld brazing and welding. So I skip this slide. You can pause it and watch it very carefully and in detail. All these things I have explained in this video, and thank you for your attention to this video. I hope that you find this video very helpful for you, and you can like and subscribe to see further videos on welding and metallurgy.